Hello everyone, I'm Snigdha Kakkad and this is my channel Accelerate AI Careers. Today I'm going to discuss a very important lead code question, lead code 921, minimum add to make parentheses valid. So as you hear the name, you might relate it to a very famous lead code question, valid parentheses. So I'll show you how this question is different from that question and which approach we can take to solve it better. In the last 0 to 3 months, the companies which have asked this question are Meta. See, 16 times it's been asked, Amazon, Google, and Apple. So this question is pretty famous in last 0 to 3 months. Now, what does this question say and how do we go about it? So basically, a parenthesis string will contain only open braces or closing braces and nothing else. So a parenthesis string is valid only if it is an empty string, or it can be written as AB, where A and B are concatenated. A is the open bracket, B is the closing bracket. Either they should be together. It can be written as AB, A concatenated with B, where A and B are valid strings, or it can be written as A, where A is a valid string. So you are given a parenthesis string here in the examples S. In one move, you can insert a parenthesis at any position in the string. So, for example, if S is given to you like this, so you have one open bracket, but you have three closing brackets. So, to make it the parenthesis valid, you would need to insert two more open brackets, right? Or you would need to remove certain closing brackets. So, basically, the question asks you, what are the minimum number of moves required to make the string S valid? So, you can insert an opening bracket here, or a closing bracket to be like this. Yeah. So for example, you have been given this string again, and there is one opening bracket while two closing brackets. So here you need one more opening bracket to make the string a valid string, valid parenthesis string. In example 2, you have been given three open brackets but no closing brackets. So you'll be needing three closing brackets to make it a valid parenthesis string. So what is the intuition behind this question? So let's take example 1. And if you recall that question, valid parenthesis, how we used to solve it, we used to have a stack, and in that stack we used to track the open braces. So every time we come across an open brace, we used to push it to the stack, and every time we used to come across a closing brace, we used to pop it from the stack. And once we reach the end of the string, if we had certain braces in the stack, that count we used to return as the number of parenthesis changes which are needed to make the string valid. So you would say that we can use the same approach here, but when you use the stack at that time, your time complexity is O of n because you're going through the string, but your space complexity is also O of n because you are using an additional data structure. So is it absolutely necessary to use a stack here? So you can avoid using stack here very easily. You can use a variable called open brackets, and you can track the count of open brackets here. Suppose in example 1, as you go through the string, you initialize the variable by 0 first, and as soon as you come across the first open bracket, you increment the count by 1, and you keep on doing that, and whenever you come across a closing bracket, you decrement the count. That ways, you will have the excess open brackets count in the very end. But what if the closed brackets are in excess? In that case, you should have another variable, which is your result variable. If you don't have any open brackets and the open bracket count is 0, but your closing brackets are coming, in that case, you should increment your result by 1 every time. So for example, in this question, I initialize both my open bracket and my result variable by 0. As soon as I come across my I equal to 0, which is an open bracket, I increment my open bracket variable by 1. Then I come across my closing bracket, so I pop this and decrement my open brackets by 0. Then I come across another closing bracket, but open bracket count cannot be increased because it's 0. It cannot be reduced as well. So I increment my result by 1 because I would need to add one open bracket to pair with this closing bracket. And say suppose the question is not this easy and you might have a very difficult question. In such a scenario, you might have more open brackets and more closing brackets. So final answer would be your result variable, whatever variable you have, plus the number of open brackets you have once you have reached the end of the string. So let's take example 2 here, and I'll initialize my open bracket count also by 0 and result also by 0. So once I come across one open bracket, I'll add 1 here, then another open bracket, I add 1 again, then another open bracket, I add 1 again. So my open brackets count is 3, and I don't have any closing brackets to pair with it. So I'll add my result and my open brackets, and total is 3, and I'll return. So that's your entire answer. Now let's look at another example of my own. Suppose this is the example you have been given. You first come across one open bracket, two open bracket, three open brackets. So your count would be 3. Then you come across 1, 2, 3, 3 closing brackets. So you reduce your open bracket by 3. So your count becomes 0 again. But then you have another closing bracket but no open bracket here. Since you have another closing bracket but no open bracket, you increment your result by 1. As soon as your open bracket count is 0, but your closing bracket has come, then you increment your result. Now you come across another open bracket and another open bracket. So you would increment the count of open brackets by 2. So at the very end, when you transverse the entire string, you have 2 excess open brackets and 1 excess closing bracket. So you can add both of them and return the result as 3. So this is one of those complex cases which you have to handle this way. Now I suppose you'll be asking, why can't we use the same approach in solving valid parentheses? Why should I use a stack there as well? You cannot solve that question without using stack, primarily because it doesn't have one kind of parenthesis. It has round parenthesis, it has square parenthesis as well as curly parenthesis. So in such a scenario, keeping track of exact locations of these parentheses, both open and closed, is not possible just by count. And that's why you should use additional data structure which is stacked there. Now, since the intuition behind the question is clear, let's start coding this question. To code it, it's just simple 4 lines of code. So let me get started. I'll first take open count as 0. And I'll take my result count also as 0. After that, once I have defined it for each character in string S, I'll go through the entire string. So for each character in string S, if this character is equal to open bracket, I will increment my open count by 1. Else, the other case is only the closing bracket. So else, if the character is a closing bracket, I will decrement my open count by 1. Now, what if my open count is already 0? So if open count is equal to 0 and you have encountered a closing bracket, increment your result by 1 and you have to set your open count back to 0 because it cannot be negative. So you cannot decrement it by 1 again, right? If your open count is already 0 and you have decremented it by 1, it will become negative, which is not true, right? Sorry, it would not be equal to, it would be less than 0. So you will first decrement your open count, and if your open count is less than 0, then you will increment your result by 1 because you have encountered a closing bracket when you don't have an open bracket, and you will reset your open count to 0. And finally, you will return your answer, which is open count plus result. You can solve the same question using 2 variables instead of 1. You can use open count and close count, 2 variables, and return the result as sum of open count and close count. That's also valid. Let's run this solution. It's accepted. Let's submit. So this solution is doing really well here. Now, if you have a better approach to solve this question, do share it with me. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.